more are joining. Okay. So welcome everybody. I see some new participants also for this particular program today. We had introduction to DBMS earlier. Now it's time for us to start with SQL. So today is an introductory session for SQL. I'm not gonna start with the actual implementations and the commands which we are supposed to learn in SQL, but just a brief introduction as to what this SQL is all about. So let's begin with our discussion on what exactly this SQL is all about. How did it come into existence, and why do you need to learn it? Okay, what's the point in going in for investing so much of time learning this particular thing, SQL? We also need to understand what exactly it is. So let's begin with our discussion on SQL. It's introduction to SQL that we'll be having today. Here we go. SQL, or also called as SQL, and some purists also ask us to call it as eSQL. Okay, I prefer it to call it as SQL. I do not know what's the right way to go ahead with. Some people say SQL. Let it be so. We are not really bothered about how to pronounce it. But SQL is one word with which we pronounce this. We hardly ever say SQL. We say SQL. So let's start a discussion of introduction to SQL. Now, when you talk about any organization, there is always a need for us to store data. Now, it could be for the simplest organization where there is hardly anything. It could be a college library. Even in a college library, you'll have to store who are the members, what are the books that we have, which book has been issued to whom, what is the date when the book has to be returned, which book the book has been issued. There is data everywhere. So even if you talk about some organization, you will have the employees, the department, the salaries. Data is everywhere. If you talk about bank, there will be customers, there will be withdrawals, there will be deposit, there will be transactions. So data is everywhere. So every organization has some information need. And as the volume of that particular data goes on increasing, it becomes more critical for us to correctly organize this data. Now we say, sir, we know about it because we had a detailed discussion of what is DBMS. True. So there is where we are going ahead with. So every organization has some information need. So data, unless it has been not organized in a proper way, it will take you time to retrieve, time to get the information, because from the data that has been collected, you are going to extract meaningful part. That's your information. You're going to represent the data as per the user request. So retrieval of information from that pool of data is something which is very, very critical. Rather, most of the time we are going to perform the retrieval operation themselves. That means very rarely we go ahead updating the data. I have been always telling you, the more often what we do is we go ahead retrieving the data. We go ahead searching for some kind of information. And this piece of information that what the customer is looking out for is data or is information. You can call it anything, but then this term should be very carefully used. Data is that collection of facts and figures that we have, and information is that aspect of that particular data which the user wanted. So you represented the facts to the user in the format the user is requesting for. So that becomes information. So organization can go ahead storing data on various media. Now, when I use the word media, it could be various devices. It could be tapes, it could be disk, it could be files, it could be anything. You could store it in a hard copy. That means what we normally have something called as files. So you could store the data into the files, and those files could be kept in a filing document, cabinets, or you can say cupboards. And from where you can, from those filing cabinets, you can extract those files as and when it's required. Now this works well when the organization is small. It works well when the volume of the data is less. It works well. So it's not like the filing cabinets are always going to fail. But these filing cabinets over a period are difficult to maintain, organize. And if the volume of the data go ahead increasing, it's difficult for you to retrieve the data immediately. If I ask in a college library where they have a manual record of all the books that any customer has taken over a period of time since his membership, And if I come down to you and you are a librarian, I tell you, ask you, okay, give me the list of all the books that Aman has taken so far. Now that could be a very difficult kind of situation, because so far, since his membership, he must have taken membership 2 years back. So you will have to go through all the records, the books that you may have maintained, and find out since the time when Aman has taken membership, how many times, which book he has issued. Retrieving such relevant information, for some reason you need it. You need to understand what kind of books Aman reads. So we want to do their analysis. What are the preferences that Amar has? What kind of books he reads? So I would like to extract that piece of information. The data is already there with you. You have your logs, you have your catalogs, you have your journals in which that record has been maintained. But think about it. Aman has joined 2 years back. He has taken membership for library 2 years back. And now I'm asking you, for last 2 years, tell me which all books Aman has taken or issued from the library. It could be a very difficult kind of situation. Now, to facilitate this comes in electronic spreadsheets. Now, electronic spreadsheet has been there with us for a very, very long time. Today, when you talk about one of the most popular electronic spreadsheet is Excel. But even before Excel, we had 123 Lotus from IBM. So spreadsheets has been around with the same kind of syntax or same kind of design. We have those rows and columns have names, rows have numbers, and electronically we could store it instead of storing it manually in a journal or in a notebook. So we can, the only difference over here was, here we could store in electronic format. Earlier we used to store in journals or notebooks is what we like to store. Registers is where we used to store. Came in electronic spreadsheet. So these electronic spreadsheets improve the performance to some extent. Now, if I ask you, I can just apply one filter on that huge amount of data that I have in my electronic spreadsheet, and I can find out, I can filter out and say, okay, give me only those rows where the member's name is Aman, and I'll get all the records of Aman. I can do it quite fast. But when the queries are complex, when my requirements are complex, then it becomes quite difficult. Then I'll have to go ahead with a lot of pivot tables and other things. So it will take some time for you to do that. And then improvement over those spreadsheets. So we had manual filing first, then we came to electronic spreadsheet, and today's age, we talk about databases. So different organizations will store data on different medias. It could be from a register to electronic spreadsheet to a database. And the choice depends upon what's the volume of data that we have. As the volume of data that we have goes on increasing, you don't have choice but to go in for databases. What is a database? It's an organized collection of information. Now, it's not just about the information. Those who were there with me for databases earlier, it's not just about the information. It's not about the data. Database also comes with set of programs that will help you to quickly retrieve or manage the data. So database is about combination of two things. It's about the data that we have organized by using some data structure, where we as a user are really not bothered about what data structure is working underneath. Data structure could be trees, it could be B plus trees, it could be hash tables, it could be anything. But then there is a concept of abstraction. All these complexities are hidden from you and me as a user. So we are not really bothered about what is there underneath. What is there underneath? What we are concerned about, are we getting the data that we are information that we are interested in? If we can retrieve that information that you're interested in, that's good enough. That serves our purpose. So database is an organized collection of information along with a lot of programs that help you to manage that particular data. So it's not just about, and then I told you there is a data structure, that choice that will be made. There will be some data structure that will who will take care of physical organization of the data. There will be a lot of programs which are running in the background. So there are a set of programs. So DBMS, yeah, or if I say database is organized collection of information, when I say DBMS, I'm sorry, management system. If I go in for manage DBMS, database is definitely only an organized collection of information. But this database is organized and it has been stored correctly. But I want to quickly retrieve. I would like to carry out operations. So I need a software through which I can do that. So we come across DBMS. So this DBMS manages the database. While database was this organization of the data, DBMS, DB is database, MS is a management system. Okay. And I will use the word software for it. So DB is database, MS is management system. This management system will provide you a lot of programs which will help you to quickly retrieve the information which is there. So we have database management systems, and they have been around with us for a very long time, very, very long time. Since 50s and 60s, we have been using DBMS, various database softwares we have been using. There are different models. Over a period, it has evolved. It is not the same database model that has been used in 60s and 70s and 80s that we are using today. Definitely not. It has over a period evolved. And we had looked at various models which were there, which were suggested, which were implemented, and then there were some limitations which were identified, and then there were some changes that were made. New design came in, new concept came in. It's constantly evolving. It's constantly evolving. So how the data is organized, how is the data retrieved, what kind of operations are we allowed to perform the database? This is one area which has seen tremendous innovation. A lot of things are changing every now and then. So DBMS is a program that stores, retrieves, modifies data in the database on request. So it will allow you to perform all the CRUD operation. You'd like to create, you like to allow to read, you like to update, you like to modify. Update is modify, delete. All such operations will be allowed for you by this DBMS. DB database, MS management system. So if somebody asks you what is DBMS, the simplest definition for DBMS is it is the collection of data and various programs which help you to manipulate that particular data, which helps you to carry out various operations on that particular data, right? From storing, retrieving, modifying various operations on the data whenever you want to. So we have this DBMS. We were talking about earlier about databases. Now we are talking about DBMS. If there is a lag, do let me know if you find difficult to hear me. I'm connected on mobile today. Yesterday's rain was bad. Routers went off. Here, there are several different types of databases. Earliest time we had hierarchical databases. Then came in this concept of network databases. Then came in this concept of relational databases, and then object relational databases, and then non-relational databases. So it's a field which has constantly seen evolution. There are a lot of changes which have been happening to this particular area over a period of time. We started with hierarchical, and we talked about hierarchical, what kind of relationships can be exhibited, network, and then relationship. In network, you could have more than one parent. In hierarchical, you could have had only one multiple child, but only one parent. Network allowed you to give an opportunity to have multiple childs and multiple parents. And then came in this new concept called as relational that we are going to focus, or object relational that we are going to focus. And then with this unstructured data that is coming up, we have non-relational. Okay, so the idea as to how the data can be organized, how the data can be manipulated is constantly evolving. It's constantly evolving. So it's not stagnant. It's not a dead kind of concept. It is the heart of every system. So it is something where a lot of attention is being paid by the industry, and a lot of research happens in this particular thing, a lot of innovations which are happening in this particular area. So you could store your data in electronic spreadsheet in form of a table, and that's your Excel sheet or something like that. You could store it on a filing cabinet. A filing cabinet could be like your cupboard and kind of thing. It has a lot of drawers, and in the drawer you keep various files. Okay, I have production file at one drawer, second drawer I have employee file, third drawer I have purchase files, fourth drawer I have sales files, and so on. So you still see these cabinets in every organization, even in today's age, because there will be some information, some data that will be maintained manually as well. But then if you're a paperless organization, you will definitely have a database, not just a spreadsheet. You will definitely have a database. Spreadsheet has its own limitations. Limitation regarding concurrent access. How about one electronic spreadsheet, one Excel sheet, and 5 people want to access that one spreadsheet at one point of time? Now there is a challenge. Correct. How do you share that data between different users? Okay, even if you manage to share the data by using some technology, how do you ensure consistency? How do you ensure that if I make changes to the data, you are not in a position to handle that particular row to which I'm making the changes to data? Now that's very difficult when you talk about maintaining consistency, maintaining integrity of the data is very difficult in electronic spreadsheets, especially when there are more than one users handling that particular spreadsheets. And these are the fundamental things which are inherently supported to you or provided to you by the database. Today, we are going to focus more on relational database. And why are we talking about relational database? Because the language that we have been now talking about, this SQL that we are going to talk about has a very close relation with this relational databases. Relational databases uses this concept of tables. Now you can visualize this table as a two-dimensional array that we have been using with every column having a name. So that's the simplest kind of representation that we have. You can map your entities to a table. Remember that concept of entity set. So if I have an entity set or if I have an entity type, I say student is my type. Student has name, roll number, address, course that is enrolled for. That becomes my entity type. And then there is an entity set. There are 4 students that we have. We have, suppose, Aman, we have Anurag, we have Ashutosh, we have Ashwini, and these are 4 entity instances whose records I am trying to maintain. So we can have it in a tabular format in form of an two-dimensional array, in form of a table. So this relational databases represents those entity set in form of a table where we have number of rows and columns. Every row represents one record. Every column represents one particular attribute, one particular field, one particular piece of information, similar kind of data. Everybody's name, one column. Everybody's address, another column. Everybody's email ID, another column. And one row is information about one particular entity. It's entity instance. Okay, and this set of entity instance are nothing but rows in my table. This set of entity instance are nothing but rows in my table. So you can represent those things in form of a table, and that's your relational database concepts. Don't worry, we're going to deep dive into these relational databases as we go ahead. But to begin with, a very brief introduction. As I told you, today I'm not going to trouble you with too much of details. Today we are going to focus primarily on understanding what the SQL is. It's just a simple introduction to this particular topic, which we will take forward in detail as we go ahead. So this fellow, Dr. E.F. Codd, proposed a relational model for database in early 1970s. I'm saying early 1970s. So he proposed this particular idea. Those were the time when hierarchical and network model were ruling the market. And this idea as to how the data or entity sets can be represented in form of a two-dimensional tables, and these tables can be related to each other. We can establish relationships between them as we have what we have been doing, this entity relationship diagram. So this entity relationship diagram, the concept, the model was suggested to us long time back in early 1970s. But remember, that was an age where DBMS softwares were not available in the market. You may be wondering, what am I saying? I'm saying hierarchical and network models were available. Yes, but when I talk about not available in the market, that means you as a user or we as a user did not have a choice to install any database that you would like to install on a hardware, because the DBMS used to be supplied by the hardware vendor. So if I want to take a network database, some product, I'll have to purchase a hardware, and on that hardware, the system will come implemented. So it was not like you get a machine, Unix machine, and then you install a database of your choice. That did not happen those days. A database machine was supplied to us. And that was a time when IBM was the king. So they were the leaders. They used to supply these database systems, the machines. It is not just the software that they used to supply. They used to supply the hardware. The hardware vendor used to supply the database. So we are talking about that age when you did not even have an operating system which was separately supplied to users. That operating system was also supplied by the vendor. So vendor will give you a machine, and that machine will be configured by the hardware vendor. He will give you the operating system. He will give you the database. Everything will be pre-installed, and you did not have a chance to replace it. So those are the times what we are talking about. So this concept of relational database is quite old. 1970s, IBM, this fellow was working at IBM, where this particular concept was, this paper was presented, a relational model for database systems, long time back, 1970s. It is a basis for relational database management system. So based on the paper this E.F. Codd proposed, he was working at IBM. Based on the paper this E.F. Codd suggested, over a period, we saw a lot of companies building the products. So it was an idea suggested by E.F. Codd, and that idea was implemented by a lot of vendors. And just to tell you a piece of history, what happened about it. This idea was suggested, idea was fantastic. But looking at the constraints those hardwares had that time, IBM was not too very passionate about implementing it. Although it was promoted at IBM, as far as I recollect, They didn't even go in for patent for this particular idea. Had they done that, they would have been the only people supplying in this particular product for a very long time. So this fantastic idea was proposed 1970s. They realized, they started with a project for implementation of this idea and building a relational product, relational database product. And they closed that particular project halfway through, looking at their earlier existing database products were doing quite fine in the market. They were the leaders in the market, and they felt they require a new hardware to support it, and the new hardware will come with a more cost, and they were not willing to continue that project. They winded up that project very soon after they started, unless until they got a requirement from US military for this particular product. Then they again initiated this particular project. They started with the research. They, although had created some, what do you say, trial softwares, they would put at the client's place, and they realized it's a technology for future, but they thought it's for future, not for that times. And there is where something happened. Somebody sneaked into it and did beat IBM in development of this product. And now IBM is way behind. And this particular small unknown company called as Relational Software, who sneaked in, became a giant that we know by some other name today. So this relational model consists of following things. So when that was just a piece of history, a small piece of history. Okay, the relational model consists of following. What does it consist of? It collection of objects or relations. Now these relations, okay, the entity sets and how they are interacting between them. So that will be represented. I'm saying collection of objects, because in today's world, we will not just be working on relations, we'll be working on object-based relational database systems. So that's the kind of system that we are going to work on. So it works on collection of objects and relation. Don't worry, I'll be exploring these relations and all the things in detail with you all. And the most important thing, the basic idea that it uses is the set operators to act on relations. So if you remember the set theory, the union, the difference, and the Cartesian product and other things. So that's the basic idea that is used in this relational model. So collection of objects and relations, and emphasize, or the basic theme that it uses to carry out various operations, the set operations. And you'll find us using those things to get some very interesting outputs by using the set operations. So the basic thing that it uses is a set operation, and it ensures data integrity for accuracy and consistency. It ensures you do not have to bother about it. Data integrity for accuracy and consistency. Okay. So integrity, that means you will not have any time invalid kind of information. It will ensure that if you make an attempt to violate some kind of constraints that we have put across, the system itself will restrict you from doing that. So we are not left up to the mercy. Many amongst you may be an application developer. Okay. Or you may be working with application developers. We are not at the mercy of the application developer. Has he captured all the constraints correctly or not? We can enforce those constraints today on the relational database itself while we are designing. So if an application programmer working in Java or .NET, if he tries to violate some kind of conditions, or he ignores some kind of validations, the database itself will ensure that integrity is existing. And plus, if concurrent users are accessing it, it will ensure the concurrent access is handled in a proper way. So you either never get a stale data, and neither you get two people update that particular same row, same record at one time, and you have inconsistent data. That's just not going to happen nowadays with these relational tables. A relational database, what is it? Can be accessed and modified by using structured query language statements. So that's the relation between the relational databases and the SQL. So the structured query language, also called as SQL, or you can say SQL, I don't mind, also called as SQL, is used to access and modify the relational database. So it's a language for the relational databases. So today when we talk about relational databases and all the relational database products which are available in the market, let it be one supplied by Oracle or IBM or Ingress or Sybase or PostGRE or Microsoft, the language is the same with slight modification here and there, but primarily the language is the same. So this is the language that we use to access any relational database provided by any vendor or any commercially available relational database that's available in the market. So all those relational databases can be accessed by only a single language, and that's SQL, or you can call it as SQL, or you should call it as SQL. So that's the language which is used to access the databases. contains collection of tables with no physical pointers. Okay, so we have to have this abstract view of the data. For us, it's a table. How is the table organized? Oh, I don't know. We should not really bother. Physical view, remember the three views we have. We have physical, we have a logical view, and we have a view or a conceptual external view. So for us, the logical view matters more. So for us, a logical view will describe an entity in form of a table. I'll say, okay, it's a table, and we'll visualize it as a two-dimensional array in which every row represents one record, every column represents one field, and so on. So it's a collection of tables, and there is a relationship between these tables. Okay, and we don't really have any idea as to how it is physically mapped, or how it is organized in terms of files, or what it is the logic that has been used to map it onto the hardware. We are not really concerned. We are more concerned with the logical and the external view. So even if you have just information about what's the logical view of that particular data and what's the external view, that's good enough. You don't really have to go to the bottom to understand how it is physically laid out on the disk. What is the data structure that has been used internally? Don't really have to have any of that information. So it contains tables with no physical pointers. We don't have to worry about how the data is there physically stored. It uses set operators. So the story revolves around the set operators. So while we learn SQL, you'll realize, or you'll find how all the kind of information that you want to extract, you can extract it by using the set operators. The relational database systems are built on the basic concept of sets. In relational database, you do not specify the access route to the tables, and they do not need to be know how the data is arranged physically. So what is the data structure that is used to organize the data persistently on the hard drive? Don't have to bother about it. Whether we are using a B plus tree, or whether you're using a hash table, or you are using some C files, you don't have to bother about it. While you're trying to access the data, there is a huge database. It's a bank, and there are millions of records which are there. And you're trying to access transactions of one particular day or one particular person for a period of time. Now to access that data, remember we have, when I talked about DBMS component sometime back, we have more than one ideas that can be used to access that piece of data. And based on some historical information that you may have earlier, the DBMS can decide which is the best route, or which is the best query plan, which is the best solution to retrieve that particular data in shortest possible time. So you can think about it like a self-learning software. So what it does, today when you fire a query, today when you make a request to the database, let me not use the term query, let me put it more simpler. Today when you make a request to the database to get some information, okay, it is more of a descriptive language. So you're not going to give the logic as to how it is to be done. You are only going to specify your requirement. So when you make a request to the database to retrieve some information, you're not specifying how, you're only specifying what is that you would like to have. So you're only specifying the requirement that you have. You're only specifying what you want. You're not specifying how to get it done. Now, if you do not specify how to get it done, you all are from programming background. Without having the logic, how is any operation going to be performed? Correct? So there is somebody in the database internally, some component in the database, which will convert your what into how. So your requirement will now be translated into an equation, mathematical representation, based on which it will build a code, and that code will be executed. So look at the story as to what is happening. You are only specifying what you want. The database engine translates that particular what. You are only specifying what you want. It translates that what into how, but that how is nothing but a mathematical representation. We call it a relational algebra. So it is nothing but a mathematical representation, an equation which is being formed, and that equation specifies how this particular requirement can be fulfilled. Now, equation is equation. We need to translate into, we need to have a code if it has to run on the program. That equation is not good enough. So there is another component in the database that will translate this particular equation into a program. A code will be created, and then that code will get executed. But in between, there is something more that's happening. The first time it followed one equation and it got the answer. Next time when similar kind of request was made, it now comes with equations, and there can be more than one formulas. There can be more than one relational algebras that could fetch you the result. Now what it will do is, it will execute using some other query plan or other equation, So it will take some other equation, build a code on that, and execute that code, get you the answer. It's going to take tremendous amount of time. Correct? It's a fourth generation languages where you specify what you want. You don't have to bother about how. So that if you are going to compromise on how to get that thing done, you're not going to specify the logic as to how to read the data from the database. How do I cycle from one row to another? You're not going to specify that logic. So you have to pay some cost. No? You have to bear some cost. And the cost is the time. And with today's very fast, powerful machines, that doesn't count much. It is substantially faster. But then that's the cost that is involved. There's a penalty to be paid because you're not specifying how that thing has to be done. So somebody has to develop that particular code as to how that particular thing has to be done. And that is done by the DBMS components, the RDBMS components which are there inside. So you specified what was translated into relational algebra. There is a code which was built on that what, and that code was executed. So as you go ahead executing this similar kind of requirements over a period of time, the knowledge of the system goes on improving. Look what I'm trying to say. The knowledge base of the system goes on improving. So it now has statistical information about which idea was taking how much of time to retrieve that particular piece of information. Now, in future, when you fire a query, and if it comes with some plan is a equation, it will compare that particular plan with the previously historical data. That historical data will give it an insight whether this new plan will work better or the previous plans which have been executed in a specific period of time, they are the better ideas. So it will not just create a plan, it will not just optimize the plan, it will optimize over a period as this knowledge base goes on improving. It will also make the best choice based on historical data. Okay, last time when you fired this query, how much time did it take you? Okay, what was the plan that was used last time? So it will make the comparison and select the best alternative plan which is available. And that's nothing but the access route to the database. So there's no one access route to the database. There are multiple access route to the database, the multiple ways in which you can retrieve. You do not have to specify as a developer. You can influence it as an administrator, but you can give it some additional support things. And what could be the additional support that you could provide? The additional support could be in form of indexes. There could be different types of indexes that will serve different purposes. And you can tell the system, okay, next time you want to perform this operation, use this index and get it done. You can give that kind of proposals. So the performance can be improved, enhanced still further. But when, as a user, as an end user, when you're filing a query, we don't really have to bother about all these things. So you do not have to specify the access route to the tables. You do not need to know how the data is physically arranged, whether it's a simple text files, I don't know. Whether it's just a binary files, I don't know. And even if it's a table, even if it's a tree structure, how are the nodes of the tree organized? Don't have to bother about it at all. Things are taken care by these relational databases, or the databases as we normally call them as. So we have the clients here. We have all the clients, and these clients are making requests to the database. Okay. And this database server have organized the data into a lot of tables. There will be thousands or hundreds of tables which will be there. Each table will be representing one entity set or one relation between the entity sets. Look at what I'm saying. Each of these table will be representing one entity set or entity type or the relation between these two entities. So all that information has been captured in form of table, and it's more like a two-dimensional array with the row numbers, and every row has a heading, every column has a heading. It's more like a Excel sheet. Okay, logically two ways, more like a two-dimensional table. And then what we also have is over here something called a data dictionary. Now this data dictionary is all about metadata, information of the database. So we have this data which has been stored, and the information of the data is being stored in this data dictionary. So dictionary is the metadata, and the actual data is stored inside these tables. And all these things have been organized in your database software, your DBMS software, RDBMS software, DBMS software, all of them have been organized. You may be accessing from the client machine, you may be accessing from server, wherever you are accessing, but normally your database server for our organization will be different than your application server and the end user machine. In today's our scenario, our machine itself is a place where the database is also installed, our application is also installed. That will not happen in the real life. Okay, we'll have multi-tier architecture. We'll have a client, then we'll have a web tier at times, we have an application or a business tier, and then we have a database tier. We also call as information systems. So the database will be stored on another layer, you can say, another tier. Application will be stored on the tier. The UI through which you are interacting, that will be there on the tier, and the client will be another tier. So you have multi-tier kind of architecture that we have. In our case, it will be like my database and my machine, single, everything, monolithic, everything at one place while you are learning this course. But in real life, database will be stored on our dedicated machines. I told you about the history. I told you early days we couldn't even get a database software separately. It was supplied along with the hardware. Keep in mind, even today, there are specialized hardware for handling databases, because database requires read-write operation is something with the hard disk that we do very, very often. So we require some kind of support. We need to mirror the data. Data is critical. Data is crucial. Loss of data will result into the entire business empire collapsing. So there has to be a lot of additional services which will mirror up the data. So hardware is also different. So these database servers are specially designed hardware to manage that volume of data. And it should be a different machine that is to be there. It shouldn't be the same laptop or a desktop that will put up to manage millions of records. Okay, it has to be a specialized kind of machine with specialized kind of architecture. So the database server and the application servers normally are different. They have the specialized support for those kind of specialized operations. You cannot have your regular disk being installed over there, which will take a hell lot of time to read or write. You have to improve on some kind of mechanism through which that buffer management and everything, cache management has to be done very, very efficiently if you really want to give the user data in shortest possible time. And all those things are supported by this hardware. So we have this hardware machine on which the RDBMS software is installed. And this RDBMS software internally contains your tables, and the data dictionary is what it has. This data dictionary is nothing but the metadata, and the data is actually in the tables. But then how it is organized physically on the hard disk, on the hard drive inside this machine? Oh, we don't know, because we are not going to interact with these tables and the dictionaries directly. Our request will always go to the relational database software, the DBMS software, and the DBMS software will retrieve information from the physical HDD hard drive and give you the information. We are not really bothered as a developer. It's good to know about how it is being organized, but not necessary for you to get your work done. Oracle provides a flexible RDBMS called as Oracle database. Oh, so is the company name Oracle or is the database name Oracle? Okay. Today, the product, the RDBMS software that Oracle supplies to us in the market is Oracle database, and the company name is also Oracle. Rather, this Oracle database is the most popular product that this company has ever produced. And even today, they are the leaders in the market. They have the major share in the enterprise domain when it comes to this relational systems today. Major. I think it's more than 50% of the global market share is what they have when it comes to the relational database products. Okay, and they have all the kind of offerings. It's not that they have stuck to only relational databases. All the new innovations which are happening, all the kind of new types of database that we have been talking about, let it be from the cloud to NoSQL, whatever we have been talking about, let it be graph, Oracle has a product in each of that domain. But what is Oracle best known for? Oracle is best known for its relational database product, and that's Oracle. I'm going to tell you about this particular product. Oracle, there was never a company called as Oracle earlier. You may say, sir, it's always the case. Before the company is founded, there is never a company by that name. I don't mean that. Oracle database product came in before, and Oracle, the name Oracle for the company came in later, because the company's product becomes so very popular, the company changed the name of the company to the product name itself. Think about it. Tata's Tiago cars sells like a hot cake, and then Tata decides, let me change the name of the company to Tiago only. That's the kind of story that is there with Oracle. The company started off with a different name. And it was relatively unknown company. Remember I talked about IBM. I said it was a market leader. And it was at IBM, this concept of relational theory was introduced by E.F. Codd. They experimented on it, but they thought it is too early for the market. And they did not build a product based on it. And that opportunity was taken up by another company called as Relational Software, which over a period became Oracle. The first commercially designed RDMS or SQL or product that was RDMS product which was released by this company called as Relational Software. But the product became so hit that they thought about changing the name of the company to the name of the product itself. So they are there in this particular market right from the time when the concept of relational database came into picture. Rather, they were the first one to come with a commercial product. So they definitely will have an edge over others. Using its features, you can store, manage the data with all the advantages of relational structure plus PLSQL, an engine that provides you the ability to store and execute program units. Now here I need to warn you. When we talk about this SQL, okay, or let us jump ahead and we'll understand what SQL is. Then I'll tell you more about this PLSQL, what it is. Oracle database also support Java and XML. Oh, why did I jump in for Oracle while you're talking relational database and product in between? Because it is a global market. It's a market leader today. And we will also in our course be working on Oracle. One of the product of Oracle, I'll use Oracle database. Even the MySQL is another product of Oracle itself. So you could use any of those products. The language with which you will access the relational products will remain almost the same. Very little changes here and there. We'll try and stick to the standards and not go ahead with the vendor specific things. So standards, that means there is a standardization committee for this particular language or RDBMS. We'll explore all of that today. So when we talk about these relational systems, we have a database where the data is organized, the metadata is stored. Oh, but we need a software through which we can access that database. So this software and the data which is physically organized creates your relational database systems. So this relational database system organizes the data in some fashion in forms of tables on the disk, on the secondary storage devices. And then there is collection of softwares that ensures a quick retrieval of the data from the database. So your database contains the data, the relationships in the table, the metadata, your data dictionaries. I understand there is trouble. You may be hearing some lot of background noise. And that's obvious because I told you my wireless broadband has gone for a toss. Yesterday's lightning, all disturbed. So I'm almost in the gallery for mobile connectivity. So you have to excuse me if there is some background noise. There's somebody's cleaning the road and there is constant noise that is there, but can't do with it. We'll focus on what we are talking about and not bother about these other disturbances. Here, so when we talk about these relational database systems, it is the data and the softwares which will help you to manage that particular data. So DBM is not just about, any DBM is not just about the data that has been organized. It's also about the software which will help you to manipulate that particular data. So is the case with relational databases also. So here in relational databases, when you talk about databases in the database, DBMS, database and management systems, correct? We'll always break up that definition into two parts. And now when you say relational databases, oh, that means that database may, how is the data organized? It is organized based on this concept of tables. So we'll be using something called as tables to organize that particular data inside. And there is some metadata, information about those tables, information about the relationships. Inside the table, I will have entity representation. Inside the table, I will have the representation of the relationship between two entities. Okay. And then we'll have this management software. This management software will provide you a language, that is SQL, through which you can fire some queries, requests that you can make to the database, and through which you can extract whatever information that you'd like to extract from the database. And then this management software will not provide you to give you an access to the database directly. Anytime you have to access the data which is stored in this RDBMS software, you do not have access to those tables directly. You will always have to go through the software. And since we are going through the software, it can provide you security. What do you say? Unauthorized access can immediately be restricted because you will have to log in, you will have to specify who you are, you will have to give your credentials only there. So these are fundamental things in databases, your credentials and everything, and that will always be checked for. Data protection, data recovery, reorganization, security, all these kind of features will be provided to by this set of softwares. And we will be making use of them through this SQL and SQL or SQL as some people call it as. We don't bother with what you call it as, because anyway, even if I call it SQL and you call it SQL, the purist still say that's not how it should be. It should be eSQL. So we will not bother about how it is called. You can do a bit of internet research and find out what's the right pronunciation. The creators pronounced it in some different way, And then over a period, users started pronouncing in a different way. And today it is just called as SQL at times. So let's talk about this SQL. Okay, the language. Here we go. Structured query language. So in 1974, Dr. Donald Chamberlain, along with Raymond Boyce, remember that name Boyce, huh? Because it's going to trouble you now a lot of times, and especially those who are not just come for SQL, those who are from the engineering background who would like to also discuss the relational model in detail after the SQL course. This Boyce is going to trouble you every now and then. Okay, so this fellow called as Ronald Chamberlain and Raymond Boyce developed this structured query language called as SQL at IBM. Or a relational product was at IBM, SQL was at IBM. Definitely, because EF Cod proposed this particular idea of relational model at IBM in early 90s, and a language which will be working on that particular relational model was suggested by his colleagues who were working at the same company within 4 years. Okay, so the idea was conceptualized at IBM. The relational model paper was proposed by EF Cod, who was a employee of IBM. Okay, who was a part of IBM, and his colleagues at the same place came with this language called as SQL. Okay, and that was early 1974. But that was till that time there was no commercial product for this relational database system that was designed by anybody. I told you IBM was experimenting with it. And if you go to the IBM site, you'll find a small story about it. They thought it is ahead of time. They thought it will require, and let me share some story. It will help you to remember the things. IBM was more like a purist. They wanted it to be perfect. So they actually created a product and they gave it to a lot of clients for trial as well. So it was used on a trial basis also a lot of places. And they were experimenting, okay, how does it work? So when we come with a product, that product has to be the best in the market. They were the leaders. So they wanted a best relational product to come in the market. They realized this is the future technology. So they did not give it up completely, but then they were too busy selling their existing products, did not give enough emphasis on commercial development for any relational product, because their existing products were doing very well in the market. So they were in no hurry to come with something new. And that's the time when the SQL later became SQL, still pronounced SQL. Some people call it SQL. So QL. So you can say eSQL. So don't get what is he saying? eSQL. Some say SQL. Some say SQL. Oh, that's still okay. Even when we write SQL, we normally pronounce it as SQL. We means I also pronounce it as SQL. That's how I have been taught. You make your choice. You be wondering, ye kya baat kar raha hai bar bar, how to pronounce it. But that's just a story about SQL, because there is a lot of debate that constantly keeps on happening. Some people say, no, this is not, you may come across a boss who is like very particular about how do you pronounce it. So you be ready with different pronunciations. Today, SQL is accepted as a standard RDBMS language. So today, when you have to access the RDBMS language, the only RDBMS software, the only language that is used across all vendors, right? From Microsoft to IBM to Oracle, whichever you talk about. And then there are a lot of open source, Ingress, Sybase, you talk about them. All of them use the same language, that is SQL. I'll call it SQL. They use the same language, that is SQL. And idea was proposed long time back. So 1979, a company called as Relational Software Incorporation, now Oracle, introduced the first commercially available implementation of SQL. In 1970s, it was introduced in IBM. IBM was late. I told you about that US military. Let me tell you about how this Oracle, what's the strategy that Oracle followed and how they became the market leader in this particular domain. There was one order requirement that was raised by US Navy, and that order was to be fulfilled. And they had realized the power of this particular technology, because this paper was anyway not patented by IBM. They never realized the significance of it, or they never thought anybody else could take it up, the development, because it was a challenge to developer. Because after all, a paper is only a research paper. EF Code only gave an idea. It was just a model, a paper, a concept that was represented. Somebody had to create a real product on it, and that takes efforts, that takes organizational support. It's not like anybody, any Tom, Dick and Harry can go ahead building a relational system. Now that's a challenge. It requires expertise. And IBM being purist, they had a product. They had designed a product. They had bidded for the same contract from US Navy where this company called as Relational Software had bidded for. Now listen, listen, the very interesting story. IBM and this company called as Relational Software bidded for the same kind of product. IBM gave them a timeline for delivery, which was more than 2 years. They said, okay, it will take us this much of time to deliver you the product. And the cost was also tremendous. Relational Software cut down that time by almost 40%. And they said, we can give it earlier. And then people laughed at them. People missed, IBM laughed at them. Yeah, if we cannot do it within that span of time, nobody in the world can do it. And believe me, they were not wrong. Because IBM those days, or even today, if you talk about, they had the best of the brains in the world. They knew the estimates were proper, how much time it's going to take. But this fellow who was leading this relational corporation was shrewd. He made a commitment which he could not ever fulfill. He was more of a marketing guy. He was not a guy from technology. He was not like somebody who would really go on to writing that particular software. He was more of a marketing guy. It doesn't mean he did not have a technology understanding, but he was more of a marketing guy. And he wanted to sell that particular idea. He did not have a product with him. He did not have a product with him. And since then and until today, he's the only CEO for this particular company. Anybody knows his name? Anybody knows Oracle Corporation Chairman? Come on. These are basic things that we should be aware of. Anybody who heads Oracle Corporation? Now that's bad. Pardon?
Larry Ellison.
Yes.
Larry Ellison.
Yes. And right from day one, he is the chairman. Take my word. He's a terrific. Yeah. A lot of this. Shivani has answered. Fauzan. How do you pronounce it? Fauzan? Am I right?
Yes, sir. Fauzan.
And what does Fauzan mean?
So victory.
Oh, great. Fauzan means victory. Great. Yesterday we had another name, Arbar. That means good. So these names are good. Huh? The Persian names are good. Fauzan, victory. Arbar, good. We have Arbar today? I don't know. Arbar is not for this batch. Oh, some other batch we had Arbar. Fauzan means victory. Okay. So welcome, Fauzan. I think you have joined us for the first time.
Yes, sir.
Yeah. So I was talking about the story. Give me 2 minutes. Let's have the story, because it's no fun in learning a technology just for sake of learning. Okay, all rules, this and that. There should be stories around it. Nah? It will help us to memorize. There should be some light part of the entire learning process. So this company, IBM was a leader. They did a right estimation. They said it will take us 2 years to give this particular product. And everybody believed on IBM. And then this company bids for the same project and says, I can give it way earlier, quite earlier. And that too at a less cost. And IBM knew they cannot fulfill their commitment. Rather, this company, Relational Software, also knew they cannot deliver the product. 20 years down the line, when he was asked, okay, how did you bid for this particular product when you did not really have a capacity? Larry was asked in one of the interview, and he opened up his mind. He told what happened. He said, I knew we couldn't develop a product, but I also knew the kind of system that we'll develop. And when the client, that US Navy, starts using it, it will take them years to understand what the system is, and also years to find out the bugs that may have been incorporated by us, while IBM was trying to come up with a software which is perfect with no bugs, or it will fulfill the requirement to 100%. He said, I knew US Navy will take time to get familiar with this particular software. It was a new technology. And by the time they realize there is bug, I'll fix up those bugs over a period of time. So while he promised that I'll deliver the product in lesser time, he actually took more than double the time to give the final product, because the company, the organization, US Navy, for them to realize they got the product in time, deadline they got the product. And there is where this Rational Software got the biggest order in their life, right? And there where the company started blooming. And then they became popular across the globe. And that was a turning point for this organization. And this particular product that they designed became so very popular. But by the time the people could understand what are the flaws, how it is, where there are problems, this team constantly kept on fixing those problems. So they actually sold an incomplete product to the company, to that particular US Navy, and they made money out of it. They made money out of it. And then over a period, they kept on improving, they kept on improving, they kept on improving, and IBM lost the race at the very early stage itself. While they had the idea, they had an experimental product which they had already put at the client space, but then they were trying to create the perfect kind of product. They were taking feedbacks from the client. Relational software did not take any feedback. The first product that they created was for the first client, and they made it a success. And they actually sold them a product which was not complete. But the US Navy never realized it. Before they could realize that this particular software is not complete, IBM, the Oracle had fixed up that particular problem. So that was never realized by them. So it was more of a marketing gimmick that made Oracle get that particular deal. So this SQL is a descriptive language, as the statement describes the desired results instead of necessary computing steps. That means if I want some information, I want what's the salary of Fauzan. So I'll not tell you how to get the salary of Fauzan, how to search in my table. Do I have somebody called as Fauzan? I'll rather say, okay, get me the salary of Fauzan. Okay, I'll say select the name and the salary from this particular employee table. That's it, done. So we'll only specify the desired result, what we want. What? Remember, we never specify how. How is taken care of by that particular system. Database and the system. Two things, database and the management system. That system, the software that is there, takes care of building a logic that can retrieve you and give you the required information in the format that you would like to have. So this SQL is a descriptive language. It's more of a declarative language. You will not specify how, you will only specify what you want in form of a statement, and that's a query, what we call as, and that query specifies what we want. And we do not specify how that thing has to be done. The logic, how we move from one row to the another, how do I search? Nothing, no searching logic, nothing is to be specified. I tell you, okay, let me know the total payout for department number 10. So we have some department, say sales, and how much is salary that we paid for this, all the salesmen in my company in the last quarter. Oh, you just give the same requirement. What I said right now is the same thing that we will talk to the software. So it's so very easy for anybody who is from non-computing background to fire such requests. So if you're a manager and you want to get that piece of information, within no time, you can start firing this kind of request through this language, and you can interact with the database and generate the expected results, because we are specifying only what we want. We are not really bothered about how the things have to be done. So this structured query language, or SQL, you may also call it SQL, I don't bother. To access database, we execute structured query language. That is a SQL statement. So any data that you would like to have from the database, we'll make a request, we'll make a query, we'll send a desired, what you want is what we'll specify to the relational software, database software, and the software will do the entire manipulation, generate the logic, to compare with the previous execution plans, find out the best plan, and there is always something called as optimizer that will optimize it, and then give you the result in the best possible format. All those things will happen for you automatically. ANSI, okay, that's American National Standard Institute. We all are familiar with it right from C days, and they are the leaders. And ANSI is all about standardization committee. They can standardize anything for you. They can standardize weights for you. They can standardize distances for you. They can standardize anything that you give. They standardize programming language like C, C++. They standardize this language SQL as well. So the ANSI, American National Standard Institute, standardized this particular SQL as to how you can, any company which is coming with a relational database system, what kind of structure, what way you will talk to that database. So this is the only place where we have seen all these commercial vendors for the databases collaborating with each other, coming up with a single way of interacting with the database softwares. So you may have, say, let's take an example. IBM has one relational database product which is very popular called as DB2. Oracle, that is this relational software incorporation, has this particular product called as Oracle. Listen, I told you about that product. So the company name was Relational Software Incorporation. Product that they sold was Oracle. The product became so very popular that they changed the name of the company from Relational Software Incorporation to Oracle itself. And today we know Oracle as the biggest organization, giants. They have turnover which is much bigger than a lot of countries across the globe. They are giants now. It's more like a state. More like a state means more like a country. They will influence the decision makers across the globe. They are giants. They will influence our future, kind of thing. Anyway, so this uh, American National Standard Institute came with the standards as to any vendor who provides this relational database software. In what way are you going to interact? And all these organizations, right from IBM to Microsoft to Oracle, they agreed on to it. Okay, we'll have this way, this format of instruction to talk to the database, and that has led to popularity of this, because you may change your vendor, you may move from Microsoft to IBM to Oracle, but most of the statements that you have written with minor changes, they'll still work unless you are not using the vendor specific commands, because every vendor will give something more. Na? But if you use the standard commands, your statements will still work even if your underlying database changes. Tomorrow you're not happy with Oracle, they're charging you very high. You want to go in for PostgreSQL, go ahead. You change your underlying database. Don't have to bother. The same queries will work over there as well because it's standardized for everybody. Language contains large set of operators for partitioning and combining relations. Relation is that two-dimensional table that we have been talking about. So we can partition those tables, we can combine those relations, get some output out of it. We will be learning something called Cartesian products, all possible combinations we can have. So it is with these operators that this particular language provides, will be carrying out all these operations. Database can be modified by using SQL statements. By using the SQL statements, you can also modify the data. You can retrieve information. You can have various combinations of those relationships. Remember, concept of set, union, intersection, Cartesian products, difference, symmetric difference. It's all based on the set theory. It's all based on the set theory. The entire relational is based on set theory, nothing else. What's the task of SQL? It provides statements for a variety of tasks, including querying the database, inserting, updating, deleting rows in the database. That's what we normally require. Retrieve information, insert data, update, CURD, create, update, modify, delete, all those things into the table. And table is that structure in which we have logical structure. A table is a logical structure. We do not know how it is physically organized. It's a logical structure where we say it's a two-dimensional table, rows and columns. Every row is one entity instance, one record, and every column is one attribute, one field. Creating, replacing, altering, dropping objects. Oh, it's not just about the data, it's also about the design of the data. We can create those tables, we can replace some data, we can creating, replacing, altering, dropping objects. Now what is the object? Object can be your database. In relational tables, tables are not the only object. We have indexes, we have sequences, we have triggers, we have functions. There are more than 13 odd objects that are there inside this database, because they will all be required for fulfilling our objective, quick retrieval of data. So tables is not the only thing that is there in the database. There are n number of other objects which are there, and all those objects can be created, replaced, altered, dropped, means deleted. We can do all those things by using the same SQL, and we are going to learn to handle all those objects. Although the SQL, while we learn, I'll create a foundation for you, so that tomorrow if you go in for a developer track or you go in for administrator track, you become a DBA or you become a developer, a Java developer who wants to access database, I want you to be comfortable with both of them. So the foundation which is required for you, you may make your choice. I do not know. Some of you may have come with over here, keeping in mind, okay, I would like to pursue administration, database administrator as a career. Okay, this is the foundation for you. Oh, you feel, no, I want to be a developer, I don't want to go into administrator track. This is the foundation for you. This is something that I'll make sure you are aware of all the fundamental things that one needs to know, whichever track that you may pursue later. Controlling access database and its object. Everything can be done through SQL. We can grant permission, we can revoke permissions. There are commands over here through which we can decide the role. Okay, manager will have this kind of permission. Okay, clerk will have this kind of permission. Okay, you can do this. This particular user will not be in a position to see this database. Abstract view. Only show him what he needs. Do not give him access to unnecessary details. Guarantee database consistency and integrity. So those integrity constraints will not be violated. You will never have a cell in which, or a attribute in which you store a value which is beyond the domain, because you already specified the domain. Okay, and remember that parent-child relationship we talked about, integrity that has to be maintained. If there is a related table, and if I delete the parent, the child should also get deleted. All those things will be enforced for you automatically. SQL unifies all of the preceding tasks in one consistent language. So one language to carry out all these operations. And believe it's simple. It's really simple. Only thing is, how much do you explore? You can finish, you can have a feeling, only a feeling, not real thing. You can have a feeling, okay, I have done SQL. There are books you'll get SQL in 10 hours, SQL in 1 day, SQL in 7 days. Oh, you can get going, you can start. But to really understand it, it takes some time. And we are going to explore it in detail. Every aspect of it's what we're going to explore. how to give various query alternate plans, how can we influence it, how we can extract data. We'll work at the low level, the logical level, the view level, and every aspect of SQL we're going to cover. SQL language is for everyone. It is for the architect, it is for the database specialist, it's for the application programmer, it's for the data analyst. It has everything for everybody. The strength of SQL provides benefit for all types of user. It can be an architect, okay, who is trying to decide about how the data is to be organized. It's for the data specialist. Okay, he would like to assign permissions to the user. He would like to check, install safeguards on the tables and so on. It's for the application programmer. Programmer is more interested in querying the database, getting the data from the database, altering the data from the database, or deleting some database objects, updating some database object. And it's for the database analyst. He's not going to create or delete the tables. He's going to fire a lot of complex queries, and he's going to get he's going to extract some insights from the data that is there. So it's one language for everybody. So even the architect is going to use the same language for describing and creating databases. Even the database specialist for putting those safeguards and constraints and validations, he's also going to use the same language. The application programmer, like a Java or C++ programmer, is also going to use the same language. And the analyst is also going to use the same language. Think about it. So any role that you talk about, and you'll be surprised when you talk about the job roles. I was just looking at yesterday, just because it should excite you. Why should I learn? One of the slides that I have over here is why should we learn this? So over there, when I was looking at some current trends at Indeed.com and in US and India, when you look at the job posting, I was just searching whether SQL is mentioned in that job requirement. And believe me, SQL was mentioned for more number of jobs than what JavaScript was mentioned or what Python was mentioned. Take my word, go and do a research. I did it yesterday. I was at Indeed.com. I searched in US and in Indian job listings, and I could do that analysis. Again, data mining. I did some analysis and found out how many job postings over there on Indeed.com mentions about SQL. Okay, and it scored more than Python, which we feel today is the hottest technology. I'm not saying they require only person knowing only SQL. I'm saying the jobs, the skill set requirement also had SQL. It could also have Python. It could also have Java. It also had SQL. Okay, it's good that a programmer knows SQL. So it was leading more than JavaScript and Python. So that's the kind of popularity which is there. The purpose of SQL is to provide an interface. Hold on, we have a message. Yeah, Abhay is right. Along with React.js, they also need SQL and MongoDB. Very true. Very true. And now that Abhay has mentioned this particular thing, there is a lot of misconception. People feel, okay, with no SQL coming in, I don't require SQL. Oh, that's a myth. That's a very wrong notion in your mind. I'll clarify that as I go ahead. It's like with no SQL coming, SQL will go off. Oh no, that's just not going to happen. That's just not. They both complement each other. It's not like it's a replacement or something like that. That's just a wrong kind of notion that is there. Oh, I need to go in for MongoDB. I need to focus on no SQL. SQL is a dead story right now. Forget. It's a wrong notion that you are carrying if that's the kind of impression that you have. Okay. They will complement each other. Take my word. They will complement each other. They are not going to replace each other. And to tell you, if you are thinking about with this social media coming into picture, listen, now, since Abhay took up this particular topic, I'm talking about it. Abhay, which is a recent phenomena, SQL or no SQL? Abhay, since you mentioned about it, which is a recent phenomena? SQL,
sir, SQL.
Or no SQL?
SQL.
Oh, you are very right. And surprisingly, people feel no SQL is the latest phenomena. No SQL has been there around even before SQL. So today with this advent, surprisingly, Abhay got it right. I have seen even developers, people working on databases feel no SQL is an in thing today. MongoDB, MariaDB, and then over there we have this Node.js, and everywhere we use this no SQL nowadays. Fine. No SQL was introduced in 1960s. It's not today's phenomenon. It's there in this particular market. Only thing with this social media, unstructured data becoming, generating very fast, volume of the data increasing, it has found its application now. But it has been there even before SQL came into picture. So SQL is a recent phenomenon. Surprisingly, Abhay got it right. Okay, it seems Abhay has did some research on it. And take my word, if you ask the best of the people, say, oh no, no SQL is the latest thing that is there in the market. Oh, it has found latest applications today. It was designed even before SQL. So they are there. No SQL is there right before. If no SQL was an answer for everything, SQL wouldn't have come into existence. No SQL came in 60s, and we are talking 74s and 79 when the first commercial product was designed by this relational software. So don't worry, it's not going to replace. It was there 2 decades before SQL came into market, and SQL has thrived and grown and became popular while there was no SQL always there. So take my word, it is not a replacement. Both complement each other. They both address different needs. In this, SQL differs from general purpose programming language like C and BASIC. Now, can anybody tell me how does it differentiate differs from C and BASIC? One thing is, in C and BASIC, you need to specify how and what. आपको क्या चाहिए और कैसे करना है. Both the things we have to specify. Anything else? Anybody quick? Can you tell me how does SQL differ? Abhay, it seems you have done research on it. Can you tell me how is it SQL different than C and BASIC or any other language, C++ or Java? Anybody want to make a guess?
Sir, hello.
Yes, go ahead.
Sir, I have done research in JavaScript, in React.js. Sir, the basic vanilla JavaScript, the SQL is different, and when we make some clones like WhatsApp or like using React.js, the stack used is MERN stack, that is MongoDB, React, Express, and that. And
Correct.
also we use Oracle to make the stack, another stack.
Correct.
So in vanilla JavaScript, the purpose of this SQL is different, and when we use React JavaScript, like cloning and this, we use this Oracle and this MongoDB concept.
Very true. Everywhere you'll have more of flavors also. Microsoft is TSQL. Everybody, there are flavors of it, but the basic idea still remains the same. How you're going to use it in case if you really have to interact with this. And no software is ever developed by only creating one thing. You always have a software stack. There are a lot of things that will be working with. But here, when I was talking about it, till recent past, the language SQL did not really supply. Somebody has given an answer. Fauzan says, we don't have to worry about formatting much in SQL, but in C, we need to keep formatting in mind. Fauzan, I will not completely agree to this, because formatting is something which is must. Because unless and until the data is not represented in the right format, nobody will appreciate. Through SQL, I can create a report with proper formatting. I'm going to teach you how to generate reports from SQL, which can be directly printed. And we will create those page layouts, margins, and everything is what we're going to do. The major difference, anybody? Oh, yes. Pariksha says she's less concerned with accessing data. Shivani says SQL is mostly used for storing and C for processing. Yes. Okay, yes. But in C, C++, in BASIC, you need to specify how, what, and how. Here we only specify what, we don't specify how. And plus, what I'm saying is not 100%, right? Till very recent past, we did not have programming constructs over here. We did not have if else, loops. Those kind of advanced constructs were not available in SQL. Were not available. We had a flavor that is PLSQL. And now this PLSQL, programming language for SQL, where all this exception handling, then loops and additional support that we require, any full-fledged programming language will provide, that was supported by PLSQL. But PLSQL is what Oracle provides you, a programming language support for SQL. Likewise, Microsoft provides some other programming language support. IBM provides another programming language support for SQL. So SQL on its own did not, I'm not saying does not, did not really have support for those selection constructs, looping construct. So that kind of support was again, I'm emphasizing on those terms, was not available in SQL. So that's how it differed from C and BASIC. So you may file a simple statement to Oracle database. You can say select department name from departments, and I'll get list of all the departments. How simple it is. How did he select it? Oh, we don't have to worry about it. We just have to send our query to the database. Database system software will do, and whatever has to be done, it will give you the list of names of the departments that you had asked for. You don't have to bother. Everything will happen automatically. That software will do the magic for you. If you talk about the features of this particular software, it allows large number of users to access and manipulate data. Concurrent access at one particular point of time, thousands of users accessing database, perfectly all right. Provided you have the best of the hardware also supporting it. Easy to learn and use. That's why it is popular. It is even today ranked among the first top 10 popular language across the globe. Very near to natural language English. So it's not like syntax like C, C++ or semicolon and curly braces and round brackets. It's a nightmare to write the code. Remember the syntax for C, C++, Java, very, very difficult. So it's very near to natural language. The way we speak, if you know English, you almost know half of SQL. Does not have to be complex structures like generalized language like C, C++, very simple to fire statements, functionally complete. With SQL, you can define, retrieve, manipulate data, and as Preksha rightly said, it's mostly meant for retrieving information. Yeah, that's the requirement that we normally have. But you can define tables. It's meant for everybody. Na? It's not just for end users, application developers, Preksha. It's for the administrator also. Administrator will create tables. User will extract information. It's a language for everybody. So it's functionally complete. It will fulfill the requirement of a database administrator. It will fulfill the requirement of data analyst. It will also fulfill the requirement of an application developer. It will fulfill everybody's requirement. An important thing, automatic navigation of data. If I tell you, get me list of all those people, listen, get me salaries of, or let me know who earns the highest salary in my organization, and from department number 10. Or for that entire table has to be accessed. We have to search who belongs to department 10. Oh, what's his salary? We'll have to move from one record to another. Last time we said select department name from departments. So I wanted to have all the department names. That means I'll have to go through all the records. So here you do not have to bother. Think about C language as a programmer. What you'll have to read the first record, then write the next statement, move your pointer to the next record, read the next record. Oh, nothing of that has to be done. The navigation by one row to another will happen automatically for you. You need not deal with the rows one by one, nor do you have to worry about how the physically stored and retrieved. How is the data retrieved? You don't have to write a logic. How will I move from the first record to the second record, second to the third? Don't worry about it at all. Everything, navigation for those records will be done automatically for you. We will only work with logical level. You need not be concerned as to how is the data physically organized. Once I give you the type information, that the table design, that should be good enough for us. We don't really have to bother as to how the data is physically organized. Fauzan says, in C, we'll have to work with file handling to act like a database. And Fauzan, for your information, at the bottom of Oracle, the RDBMS is also file handling. The only thing is, we do not do that file handling. So you said it right. Oracle itself is implemented in C, C++. So they will also do the file handling. But that's this point right now what we are talking about. We are working at logical level. Physical level is again files. There is nothing other than that. Physical level is again files. Somebody will have to create those files, but abstraction, that's the right word. Everything has been abstracted. We are working at the logical level and the view level, external level. We are not bothered about how the things are managed. The company who has built this particular relational software, they will take care of the C file handling and retrieving it and mapping it. All those things will be done by them. We don't even know in the catalog how the data, how it is physically organized. We need not bother about it, how it has been physically organized. All SQL statements use optimizer. That's very good. So I told you about more than one plan as to how a query can be executed. So when a plan is devised, when you make a request, it comes with a relational algebra. And that algebra is not the only algebra, not the only equation, not the only plan in which that problem can be solved. There can be multiple plans. So based on some statistical data, it will select which is the best plan. So there is always this optimization that will come into picture. A part of RDBMS that determines the most efficient means, we call it as a query plan for accessing the specified data. It will do it automatically for you. It processes a set of data as group rather than individual units. So you don't have to bother one row. You will get a chunk of record. You will get a block of records and you work on it. It uses statements that are complex and powerful individually and therefore standalone. One statement is like one program. Think about a C programmer. He'll have to write the code first, compile the code, and then execute. Forget. Here you want fire one query. That's like one program. So that statement can be very complex. It's just like one program. You fire on the console, on the prompt, and it'll get the work done. Control statements such as begin, end, if, then, loop, exception handling were not initially a part of SQL. Listen, were not initially a part of SQL. But the latest standard, that is ISO IEC 90754, we have introduction of these constructs also over here. So we don't have to bother about, oh, I don't have if-else construct. Cannot do conditional test and everything. Forget. Everything is available now. What's the aim of SQL? The aim of SQL is to provide user with a medium to ask for the data that they require. So you're going to ask. You're going to specify what you want. You're going to make a request. This is what I want. Ask. Don't forget. This is the basic objective. Ask with a medium. Provide a user with a medium to ask. It's a via medium through which we'll talk to the database, relational database, and tell it, okay, I want this. Okay, you just specify what you want. You give your wants, and your wants will be fulfilled by that particular database. When you talk about SQL command, there are different types of languages that will come across: data manipulation language, data definition language, data control language, transaction control, and everything. And different users will require them. An administrator will use DDL to most options because he's going to create those structures and other things. Data control language, somebody's going to give you permissions. Data specialist is going to give you permission. Okay, Aman can have permission to access this data, and Sandeep has permission to access this data. Okay, Sandeep does not have permission to delete records, but he can read records. We require data control language. Okay, we require to manipulate data, read, update, modify, data manipulation language. So we have different types of languages. And last one, transaction control. Remember transaction, we have talked about so many times. Transaction, either a operation may consist of more than one transaction. We always take an example of bank money transfer. So the money transfer will involve 4 or 5 different transactions, operations to complete one transaction of transferring money. So either the transaction happens in entirety or it doesn't happen. So all that support is provided by SQL. There are various standards of SQL. What am I saying? Various standards. We mentioned only about one, ANSI. Or ANSI is not the only standard which is there. Currently, we talk about ANSI and IC, ISO, IC. They are the most widely used standards. So industry accepted committees are the ANSI and the ISO. So these two organizations, like if with almost every language, with Java, with C++, these are the committees, C, C++, these are the committees, not with Java, but at least with C, C++, these are the committee which have standardized. Same is the case with SQL. SQL is standardized long time back. It's almost, the standardized version is there with us for almost for last 40 years. Both it's affiliated with the International Electrotechnical Commission, that IEC. Same is the case with C, C++, IEC, ISO. So same over here. So there are two standards. One is IEC, ISO and ANSI, IEC. So these organizations have collaborated with each other to come with a standard. Both ANSI and ISO IEC have accepted SQL as a standard language for relational databases. So you talk about any commercial relational database product which is available in the market, the first being Oracle, any commercial relational database product available in the market, all of them use this same standard language. There are so many versions of SQL that came in over a period of time, and specifically talking for the standards. Oracle 86, that was a time when ANSI came the first standard. 86, way before you were born. Most of you are not even born at that time. So that since then, SQL exists. And I'm talking standard. Even before that, SQL existed for almost a decade. Almost a decade before that it existed. Okay. But then in crude form, the structured format that we see, first standard was formalized by ANSI in 1986. 89, we added this integrity constraint. Remember the integrity constraint? Okay. If the parent is destroyed, child will get destroyed, domain constraints, and all those constraints. Conditionals, like what's the value, what's the domain, what's the possible values that variable can hold. If I have a roll number in class, there are 60 students, roll number cannot be negative, roll number cannot be greater than 16. Constraints. So all those constraints can be laid. So that kind of feature was added long time back, 1989. Then 1992. I'm just talking about highlights. There are a lot of additional things that happened along with it. In 92, entry level SQL 92 was adopted. In 1999, we had this regular expression, pattern matching. Like say, now if I ask somebody, quickly you have to answer without any time, without taking any time. Mayuresh, give me the spelling for Fauzan, quick.
FAW.
Not to read, Okay.
FAWSNN.
Okay. Now you said FAW and you are wondering, आगे क्या होना चाहिए? Okay, fine. You can give a pattern. You can just say, I don't even know, FAU, Fauzan, or FAW. I don't know, but I know for sure it sounds something like that. It sounds something like that. So I can also compare with the way the things sound. Those kind of comparisons can also be done. If you do not know the exact spelling, I can say, okay, it starts with FAUW, I don't know. So I can say, okay, like that thing, regular expression, I can give expression. Okay, something like that. But pattern can be given. Remember we had done in Java pattern matching. So similar kind of pattern matching can be done with regular expressions over here. So 1999 support for patterns, triggers, and embedded SQL in Java. So combining, application developers can embed SQL statement in Java program. That happened in 1999 when Java was evolving. 1996 Java came in, and very early in the Java's lifetime, we saw this embedded SQL. Embedded is Java statement being written inside, SQL statement being written inside Java. and that support was provided in 1999. Triggers is some like an event we have been learning in SQL, in Java, event handling. Something happens and it should be notified, and on notification you want to do some operation, so you press a key event has happened, so you want to do something. Likewise, somebody touches a row, somebody deletes a record, somebody updates a record, that's an event, and you would like to fire some operation based on that event. So that triggers concept was introduced in 1999. So we are going to learn all of them, don't worry. And 2003 saw this introduction of XML concept into it. 2006, storing XML data in SQL database, XML query language integration was done in 2006. 2008 standard, order by outside cursor definition. Now that's very complex. I'll talk about it when this is order by, like we want to create groupings. So those can be done. 2011 saw addition of temporal data. 16, row pattern matching, polymorphic table function, and JSON. So you will be aware of this JSON. So these JSON objects now can be supported in SQL. 2016, very recently we had this support, and JSON becoming very, very popular in web technologies. And 2019, that means it's constantly evolving. It's not like it's dead. 1974 mein kuch hua. The first time SQL was introduced is 1974 when the concepts were introduced. Okay, so it's not like the same standards are there. It's constantly evolving. MD array means multi-dimensional array types and various operators have been introduced in 2019. So it's constantly evolving. But SQL standard provided by ANSI and ISO are not the only standard which are there. We have the European vendors having their own standard called as X-Open standard. We have IBM, which also has its own standard called as SAA. We have the NIST, that's National Institute of Standards and Technology, that's in US, a Federal Information Processing System called as FIPS. So there are multiple standards for SQL, and ODBC, a group of database vendors formed SQL Access Group to address the problem of database interoperability. That means the DBMS softwares to be interacted. We wanted some kind of medium through which we can handle the legacy softwares also. So that ODBC standards were also introduced long time back, 1989. And Microsoft has a very good support for them. So there are several standards. We are concerned with the most popular standards, that is ANSI, ISO, ISC. That is what we are going to focus on, not the other standards. Okay. And then something that the concerned topic for you, why should you learn for SQL? And this data that I have reflected here comes from indeed.com. So it's not hypothetical data, it's from Indeed. Number of data analyst job that mentioned the specific skills. So if you search for data analyst job, and if you look out for, how many data analysts should know SQL or SQL? So look at that, 55% of data analyst job. And data analyst, why I have picked up? Because that's hot right now in the market. We hear so much about data analysts and data scientists and other kind of thing. So data analyst job who are going to find insights into data. Today's world is about data, correct? And if you look at this data analyst job, which are on rise tremendously across the globe, 55%, more than half of the job mentioned that they also want SQL as a knowledge base from the developer and data analyst. So every data analyst, every other data analyst, okay, should be knowing about SQL. Python, Hadoop, R, machine learning, Spark, Scala. Look at the comparison and look at the where SQL stands. And you do a research on your own. Go and find out and look at the job skill set. You will have Scala along with it. You may have Java along with it. You may have Python, but SQL will something that will always figure. That means you have to have some understanding of SQL in that area. What are other jobs that require SQL? Business intelligence, BI, data science, database administrator, web development. We had Abhay talking about web development. You ought to have knowledge about SQL in different forms if you want to go in for web development. And what are the job positions which demands knowledge of SQL today? Backend developers who will make our servers work correctly, the logic, business logic that is working, they need to, because they will be actually accessing the data. They need knowledge of SQL. Administrator requires knowledge of SQL. Analyst requires knowledge of SQL. Data scientists also require knowledge of SQL. Everybody, all these jobs, any of these jobs that you are thinking about making a career into, all of them demand that we need to know about SQL. Why learn SQL? World standard for more than 40 years. What more proof you need for it to be something, a trusted technology? World is not going to switch over to a new technology just because it's new and fantastic. They want reliable. And this has proven its reliability for last more than 40 years. More than 40 years from the time when the first standard came in. So 40 years it is working across the globe. So since 1970, SQL has been used in almost all relational systems across the globe. As the world continues to need access data more, knowing how to use SQL to either work with programs or database will put you onto fast track to access tons of data at your fingertips. So today, if you really want to make the best of this data opportunity which exists, knowledge of SQL is going to help you tremendously. So SQL is a skill that everybody needs to know, right from a developer to a manager who may not be a programmer. He also needs to have this SQL. So there is enough of opportunity reason why one should go in for SQL. So that was a brief, or not a brief, quite a detailed kind of introduction to SQL. Next session, we actually start off with learning SQL as a language, and we'll go deep dive into it, what SQL is and other things. So that's all that I had to share with you for today. Any questions if you have, you're most welcome. Today it was more of a one-way session. You had to listen to it. There was not much of interaction. That's okay. Some days it is the case, but henceforth that will not be the case, or normally that's never the case with us. Those are with me for early days, you know. But then this was more of an introduction, correct? So we had an introduction. It's time for us to jump start with SQL. Next session, we go ahead with SQL in detail. Any question as far as today's session goes, you are most welcome. You can ask those questions. And otherwise, we are done for the session for today. If you liked what we discussed, if you understood what we have discussed, please click on yes. That was a very short introduction to SQL. So your feedback is must. Okay, give a thumbs up if you like it. And it was, so I also feel good. Na? In the classroom, I can see your reaction. Here, the reaction is only this emojis kind of thing. So there has to be some motivator for me also. Na? Anant, if you don't like it, say, you can always disagree. You can always raise objections and we can discuss it. Na? I'm not no God. It's not like I'm never going to commit mistakes. I may commit mistakes. Very often I may commit mistakes. And learning is all about committing mistakes and overcoming those mistakes, isn't it? So we will go ahead in this journey. We'll experiment. And this is an evolving language. It's not like what I knew 4 years back is the same thing today. Things have changed and it will change. So we'll just follow it. I'll show you the right resources to learn, to touch upon, so that you will always have the latest and the correct information to master this technology. Anand, Anurag, give a feedback, something at least. Say no if you have some. Shivani Pandita has given a reaction. Shivani Sorte, give some reaction. And if you're working on mobile, hold your phone horizontally so you can give a reaction. Shivani has given. Oh, thank you, Shivani. Thank you. Okay, thank you all. Only one short thing. We will not meet tomorrow. We'll meet day after tomorrow for the session. So I'll send you an updated plan. So day after tomorrow, we'll meet for a session and we'll continue with SQL. I understand some of the students from D.Y. Patil College have some problem. They have some programs going on. So today evening, Deepak has promised me that he'll give me feedback as to how the program goes about. So tomorrow we'll not meet. We'll meet day after tomorrow and we'll continue the session. So updated thing will be sent across to you today. That's all for today. I'm here for another 5-10 minutes. Like always, if anybody has a query, you are most welcome. That's all for today. Thank you all. Take care. Love you. Bye-bye.